Welcome back to the Home Lab, and I've got an interesting experiment for you today, and it's a bit of a puzzle, and I want to see whether you can work it out. So this is a lovely little puzzle and experiment that's often done at the early stages of A-level. And what I want you to do is to see if you can work out how to weigh a retort stand using only a tape measure and a known weight. So this is an interesting little experiment, and the more you think about it, the more you realise you haven't really got enough equipment to solve this problem, how to weigh your retort stand. But in fact, you have, and there's one little trick you need to know to do it. So give it some thought and see if you can work out too how you would go about this. So have you had any luck working out how to do this? So here's the retort stand, and I'm going to show you the one trick you need to know to solve this problem. And it's a really, really useful one. I've gone on and on about this to my students. Don't think about this as a complicated shape. It's totally irrelevant. What's relevant to this experiment is how much material we've got here, what its mass is. And the key to finding out its mass is to think of it as a single point. So don't worry about the shape. So if ever you get complicated questions about this sort of thing, think about where could all the mass be considered? Where is the centre of mass? And the very easy way to find the centre of mass is to balance the object. Now, I'm going to talk about the centre of mass being at the balance point. That's just for the ease of the video. I think you're aware, of course, it's along a line that's vertically down through that point. But what I'm suggesting is that if you can balance the retort stand, you can forget all the material here and all the material there. You can crush it down so it exists at just one point here. And we're going to use that to work out what the mass is of our retort stand. So we're going to do this experiment properly on the bench in a minute, but just to show you, if we found that balancing point that's so important, we can now say that the moments this way in the anti-clockwise direction, this force times that distance, is equal to this force in the clockwise, or causing it to turn clockwise, times that distance. So what we're going to do now is hang a weight off this end and get it off balance. So let's see how we get on with this. So here's our retort stand. If we know where the balance point is, we can consider the whole mass of the retort stand to be concentrated at that point. So forget the shape of the retort stand, imagine it all crushed down to that point. We can hang mass on this end. Probably going to end up dropping this. Here we go. And clearly it's not going to balance anymore. There's a clockwise moment. So I'm going to slide my finger up here until I find a new balance point. So, can you work out what we do? We now know 3 of the 4 things we need to know to work out the mass of the retort stand. We've got this distance times this force must be equal to the distance from the pivot to the centre of mass, which we can measure because we mark the centre of mass, multiplied by the unknown force of the retort stand. So we've got a known distance, a known distance, a known weight, and an unknown weight. And all we need to do is calculate what that unknown weight is, and then we know the mass of the retort stand. Okay, so let's go to the bench and do the experiment properly. Okay, so I've got another retort stand pointing towards you here, or at least a clamp end pointing towards you, just to act as a pivot point. You can say, oh, hang on, you didn't mention that apparatus, but I used my finger earlier on, so you can use what you like, but this is the way we normally do it in the lab. And here's the unknown mass retort stand. I'm going to put it on here and get it to balance. That's pretty good. And then what I'm going to do is mark on here that point where we can consider the centre of mass to be. I know it's probably a bit below there, but this line of action is the point where the moments are equal on either side of that pivot. Okay, so I've marked on the pivot point or the balance point. So what we're going to do now is take the slotted masses that we've got, and I've got 1, 2, 3, 4 here, so 4 newtons. I'm going to hang it on the end. There we go. Slide this along this way a little bit and get to a point where it balances again. So it's about there. So now we've got that point, all we need to do now is take some measurements. So I hope you remember what measurements we've got to take. We've got a known distance here and a known force there, 4 newtons. We've got a known distance here. Remember, this is the bit that I always find difficult to explain to students. The whole retort stand can be considered to be at that point. So we've got a known distance here and the one unknown, which is the weight downwards of the retort stand. And then we can change that to a mass, and we've got the mass of the retort stand. So I'll just quickly take some distance measurements. This is not particularly accurate or precise, and it's normally done with a metre rule in labs, but I've got 37 centimetres there. So 37 centimetres, and here, just lean across, again, bit of parallax, but it's just for fun this. Okay, 9 centimetres. So let's use those numbers to work out the mass of the retort stand. Okay, so now let's do a quick bit of maths to see if we can work out what the weight of the retort stand is and therefore its mass. So the crucial thing here is always lay out a diagram really neatly so you can see what measurements you need to make. And I tend to draw this before I do the experiment. A little trick I was taught by Adam Savage from Mythbusters, which is really good. I know this is not the way engineers do it, but if you draw a circle on the lines where you need some data, then it reminds you you've got to have a number in those. So our measurements were 37 centimetres this way and 4 newtons downwards. So that's the clockwise moment. So on the right hand side, let's work in metres, so we're in Newton metres, 0.37 metres. And then on the other side, we had an anti-clockwise moment, which balanced. We've got a known distance here, which was 0.09 metres. So that's 9 centimetres, and an unknown force. And I hope you can see this force here times this distance is equal to this unknown force times this distance. So we can solve for this force and then work out the mass of the retort stand. Okay, so let's finish our calculation. So we know the force that causes the anti-clockwise moment here times the distance is equal to the force that causes the clockwise moment times the distance to that force. So let's put some numbers in. So we've got the unknown weight of the retort stand multiplied by the distance to the pivot, 0.09 metres, is equal to the force on this side, which is 4 newtons, times by its distance to the pivot point, 0.37 metres. So 4 times 0.37 is 1.48 Newton metres, and that's going to be equal to the force on this side times by the distance. So what we need to do is divide 1.48, put my equals in there, so 1.48 divided by 0.09 9 will be equal to the unknown force. And if you work that out, the unknown force, that's the weight of the retort stand, comes out at about 16.4 newtons. And if we divide by 9.8, that gives us the mass of the retort stand is about equal to 1.68 kilograms. So what we better do now is get the retort stand, put it on some scales and see how close we are. Okay, so let's put the retort stand on the scales and see what we get. And not too bad at all. We had about 1.68 kilograms and we're getting on the scales about 1.72 kilograms. So we're not far out at all, and remember that our measurements weren't all that accurate or precise, but a very simple experiment gives really quite a pleasing result. So before we finish, a little bit of a story, and it's why I wanted to show you this experiment. Over 30 years ago, when I trained to be a teacher at Cambridge University, we had to visit schools, and at the very early stage of my teaching, I went to a school in Hitchinbrook, and the A-level lesson that was being done was weighing a retort stand. And I was told this in advance, and I looked at it, and I'm embarrassed to say this now, I could not see a way through this experiment. And I looked in the books and the teacher's guide, and it didn't really tell me how to do it. And I arrived at the lesson really with absolutely no idea how to do this. And I realised that when I did my A-level exams a year or two, well, it's probably 4 years earlier, there was a question about moments and levers, and I had to leave that question out. I just couldn't do it. And I can't blame my teachers for not teaching me that topic. Maybe they did. Entirely my fault for not revising properly and trying to find out which bits of the specification I didn't know. But of course, once I was taught the trick of think of the centre of mass of an object. Think of an object as being crushed down and existing only in one little point, the centre of mass. Then I understood it completely. And I've taught this experiment for at least 30 years since then. So I do hope you enjoyed that experiment, and maybe you worked out how to do it before I told you. Anyway, I'll be making lots more videos, so make sure you're clicked on the bell so you get a notification for when the next video comes out. And if you kindly want to support what I do, down in the comments below is a link to buy me a coffee. Anyway, I'll be making another video soon, and I look forward to seeing you then.